You're standing in a bus at rest without any support. Suddenly the bus starts moving and you fall back as if someone pushed you back. Why does this happen? You get back on your feet and now suddenly the bus stops and you fall forward as if someone pushed you forward this time. Again, why does this happen? To answer this question, we need to ask a couple of more fundamental questions. What keeps objects at rest and what keeps objects in motion? Let's start with this one. What keeps objects at rest? To answer this question, let's have a look at objects around us. Let's consider this chair. This chair is right now at rest. What do I need to do to keep it at rest? Well, we'll say nothing. I don't have to do anything. Objects at rest have a natural tendency to stay at rest. In fact, this object will stay at rest until, wait for it, until I push or pull on it. So, going back, what keeps objects at rest? We can say nothing. Objects at rest have a natural tendency to stay at rest until we push or pull on it. And by the way, the second part, to be more accurate, I should actually say until an unbalanced force acts on it. Here's what I mean. You see, right now the chair is at rest, right? But it is being pushed and pulled. See, gravity is pulling down on it and the floor is pushing up on it, the normal force. Then why isn't the chair moving? Why is it continuing to be at rest? Well, because these forces cancel out. These forces are balanced. So balanced forces will not make this chair move. If you want to get this chair in motion, you have to put an unbalanced force on it. So for example, when I come along, what I do is I push on it and there's friction opposing it, but my applied force is bigger than the frictional force. So these forces are not balanced. And so when I apply an unbalanced force on it, that's when the chair starts to move. And so that's why we say the objects at rest have a natural tendency to stay at rest until an unbalanced force acts on it. Cool? All right, now let's get to the more interesting question. What keeps objects in motion? Well, we might go back to this and say, we just saw the answer to this. If we want this chair to move forward, then we need to apply an unbalanced force in the forward direction. And if we want this chair to move backward, then we need to apply an unbalanced force in the backward direction. And look, if we stop putting an unbalanced force, it comes back to rest. So we might think that the answer to this is an unbalanced force in the direction of motion. That's what keeps things in motion. And if we stop putting an unbalanced force, well, it would come back to its natural state of rest. This sounds intuitive, but unfortunately, this is wrong. Why did our intuition give us the wrong answer? Because we didn't do experiment carefully. Let's go back and do a slightly more careful experiment. This time, instead of pushing the chair forward, I'm going to kick it and let's see what happens. Here we go. Here we go. Boom. What do you notice? Well, let's go back. When my foot is in contact with the chair, at this point, I am pushing the chair forward. But as soon as the chair loses contact from my foot, I am no longer pushing that chair forward. There's nothing that's pushing that chair forward. There is no unbalanced force in the forward direction. And yet, that chair continues to move forward. And for a second, if we imagine if this was right, that we needed an unbalanced force to keep things in motion, then that chair should have instantly stopped the moment we lost contact with the foot. This is how it would look like. All right, ready? Boom. See, the chair would instantly stop once I let go of it. But clearly this doesn't happen. This is not how things work, which means this is definitely wrong. So then what's the right answer? What keeps objects in motion? Well, just like over here, nothing. Objects in motion have a natural tendency to continue its motion with the same velocity until an unbalanced force acts on it. And this is not intuitive, I get it. And so let's go back and to the experiment and look at it one more time. I have the chair at rest. If I need to start the motion, get it to start moving, yes, I need to kick on it. But once the chair is in motion, it doesn't need any unbalanced force to stay in motion. Things in motion have a natural tendency to continue its motion with the same velocity in that same straight line. But you might say, Mahesh, well, this chair eventually comes to a stop. Why is that? Well, that's because of this second part of it. It would continue its motion with the same velocity until an unbalanced force acts on it. What is the unbalanced force acting on this chair making it stop? Friction! It's the friction that's pushing the chair in the opposite direction, making it stop. If it wasn't for friction, that chair would continue to move with the same velocity. And to convince ourselves, we can do a thought experiment. Say we kick the chair twice, once on ice and the second time on grass with the same force. What would happen? Well, you probably intuitively predict that the chair would travel much farther on ice before coming to a stop compared to grass. But why? They're being kicked with exactly the same force. Because ice has less friction. And that's why, because there's less friction, it takes more time to stop, and therefore the chair travels further before stopping. And because there's friction and air resistance everywhere, which makes moving things stop, it makes us feel as if moving things have a natural tendency to stop. But that's not true. Objects in motion have a natural tendency to continue its motion until an unbalanced force acts on it. And now if we put these two together, what do we get? Well, we get objects at rest stay at rest. Objects in motion stay in motion at the same velocity until an unbalanced force acts on it. And I know this is the part that's hard to digest. But anyways, this is what we call Newton's first law. And so remember, you don't need an unbalanced force to keep things in motion. When things are in motion, they have a natural tendency to stay in motion. And when things are at rest, they have a natural tendency to stay at rest. And this natural tendency of objects to continue whatever they're doing is what we call inertia. And therefore, the first law is also called the law of inertia. And now we're ready to answer the question we asked at the beginning of the video. And so when you're at rest, because of your inertia, you have a tendency to continue that state of rest. And so if the bus accelerates, then the floor of the bus tries to slide past you. But there is friction that doesn't allow that. And so when the bus accelerates, there's frictional force acting on your feet, and that accelerates your feet forward. But the rest of your body, because of its inertia, it continues to stay at rest in that same position. And look, that's why you fall back. Not because somebody is pushing you behind or backwards, but because your feet are being pulled forward. Finally, can you try and answer now why when the moving bus stops immediately, you tend to fall forward? Go ahead, pause the video and give it a try. Alright, you're moving. Because of your inertia, your body has a natural tendency to continue that state of motion. Now, if the bus stops immediately, your body would continue to keep moving until you hit the front of the bus. But that doesn't happen because there is friction. Friction doesn't allow you to slide past. And so friction puts a force backwards on your feet, making it stop. But the rest of your body will continue to stay in motion. And that's why you fall forward. Not because somebody's pushing you forward, but because your feet are literally being pulled backwards. Finally, I want to reiterate that if this part seems very hard to digest for you, you're not alone, my friend. Because we are submerged in a world of friction and air resistance, it's hard to see this. But you could look up in space. In space, there is no friction or air resistance, and that's why planets continue to move forever. The moon continues to move forever. The motion of the planets and the stars and the moons reminds me of this part of Newton's first law, and I hope it helps you too.